All right, let's dive right into this explainer and discover the high-tech, invisible mechanical hero that is quite literally keeping our digital world from catching fire. When we think of data centers, we usually picture endless racks of blinking servers, mind-boggling amounts of data, and AI doing some serious computational heavy lifting. But the truth is, none of that happens without the refrigeration compressor. It's the absolute beating heart of the cooling system, furiously working behind the scenes.
Here's our roadmap for today. First up, the heart of data center cooling. Then we'll look at screw and centrifugal compressors, followed by tech trends in the AI era, and finally, how fast restarts are actually saving servers from total meltdown.
Part 1, Heart of Data Center Cooling. So let's kick things off with a little biological metaphor. If the servers are the brains of the data center, doing all the thinking, calculating, and processing, the compressor is absolutely its beating heart. Now, you might be wondering, how exactly do you throw 40 degrees Celsius heat out into a 30-degree summer day? I mean, naturally, heat only flows from a higher temperature to a lower one, right? You can't just open a window and expect the server's heat to magically escape if it's already hot outside. If we want to dump the heat we've stripped off those servers into normal outside air, or cooling water that sits around that 30 degrees Celsius mark, a refrigerant absolutely has to be hotter than that 30-degree baseline. If it isn't, the heat's just going to stay put. So how do we force that to happen? Well, this is where the compressor works its magic, leaning on the Boyle-Charles Law. By violently squeezing that low-temperature refrigerant gas, literally shrinking its volume and cranking up the pressure, it forces the temperature of the gas to spike rapidly. Suddenly, you've got this high-heat, high-pressure gas that is way hotter than the outside air, so it can easily push that heat right out of the building. And that's exactly why the compressor is known as the heart of the refrigeration cycle. Just like your actual biological heart pumps blood to keep you alive, this machine furiously pumps life-saving, pressurized coolant through the whole facility 24/7 without skipping a single beat. Moving on to part 2, screw and centrifugal compressors. What's really fascinating here is looking at the actual titans of machinery doing all this incredible heavy lifting. We're definitely not talking about the tiny compressors sitting in the back of your kitchen fridge. Because data centers require massive, completely uninterrupted capacity, the industry heavily relies on a classic heavyweight matchup between two distinct mechanical designs, the screw compressor and the centrifugal or turbo compressor. Let's break down how these two giants compare. First up, the screw compressor. Imagine interlocking male and female rotors, literally giant screws, rotating together to trap and just relentlessly squeeze the gas into a smaller and smaller space. It's incredibly durable because of its simple structure, but the real superpower here is precision. Using a slide valve or an inverter, it perfectly adapts its capacity anywhere from 10 to 100%. It's the ultimate workhorse for constantly fluctuating server loads. The catch? When those giant metal screws are spinning at top speed, they definitely generate some serious noise and vibration. In the other corner, we have the centrifugal, or turbo compressor. Instead of squeezing gas, it uses a high-speed rotating impeller to just fling the gas outward, creating extreme centrifugal velocity. That fast-moving gas hits a diffuser, which slows it down, converting all that kinetic energy into massive pressure. This water-cooled powerhouse gives you ultra-large capacity. We are talking thousands of refrigeration tons in a single unit, with unbeatable energy efficiency at 100% full load. But there's a huge Achilles heel. If the load drops too low, you get a destructive backward flow called surging, which causes extremely dangerous vibrations and requires highly precise control to prevent. All right, part 3, technology trends in the AI era. Let's look at how this builds into the modern AI landscape. AI isn't just changing software anymore, it's physically redesigning the data center. Massive clusters of specialized chips mean power consumption is absolutely exploding, making cooling efficiency more crucial than ever. Historically, there was a major bottleneck here. Both screw and centrifugal compressors needed lubricating oil, so their metal parts wouldn't just grind together. But that oil wouldn't stay put. It mixed with the refrigerant, travel through the pipes, and coat the heat exchangers in this thin, slimy layer, which absolutely crippled heat transfer, dropping system efficiency by an incredible 10 to 20%. In a massive AI facility, a 20% drop translates to millions of dollars in wasted electricity. Literally millions. So the industry fought back with two game-changing technological upgrades. First, magnetic bearings. Instead of oil, they use electromagnets to literally levitate the rotating shaft in midair. This makes the system 100% oil-free, eliminating friction completely and maximizing efficiency. Second, the VFD, or variable frequency drive. Old compressors wasted huge amounts of energy running at a fixed speed, like 60 Hz. VFDs provide real-time motor speed control, slowing the motor down to cut power waste at night or during the winter when cooling demand drops. It is genuinely mind-blowing when you picture what this means in practice. Deep inside these ultra-modern facilities, you have these massive, oil-free magnetic turbines literally hovering in mid-air. Because there's zero physical friction, they operate in near silence, spinning at breakneck speeds, permanently maintaining maximum heat exchange efficiency without a single drop of lubrication. They are the unsung, levitating heroes keeping the AI revolution cool. Which brings us to part 4. Fast restart, saving the servers. Seriously, what happens when the lights go out? This is the terrifying climax of our explainer. Imagine a sudden blackout hits a massive data center. The backup diesel generators immediately roar to life, so the servers have power. But here is the invisible crisis: the cooling system. Standard industrial compressors have built-in safety protocols. They need to slowly balance their internal pressures before they'll even allow themselves to turn back on, a process that takes 5 to 10 agonizing minutes. In a modern AI data center packed with high-density chips, 10 minutes without cooling literally means the servers fry themselves. Total server death by overheating. Just look at the timeline to really understand the stakes here. At 0 seconds, blackout. We know waiting 5 to 10 minutes equals server deaths. So specialized data center compressors are engineered with very specific fast restart logic. They completely bypass standard delays, racing against the clock to hit an incredible 80% of their maximum cooling capacity within a golden window of just 30 to 60 seconds. They literally catch the servers right before they hit critical temperature, saving the brains of the facility in under a minute. It totally shifts your perspective on the internet, right? We always tend to think of the cloud as just data floating somewhere in the ether. But the reality is highly physical, beautifully engineered, and incredibly intense. Next time you casually ask an AI a question from your phone, I really hope you take a second to think about those furiously spinning, levitating magnetic hearts operating in the dark, racing against thermodynamics to deliver your answer.